afternoon from Rocket Lab Mission Control in Auckland, New Zealand. Today is Thursday, December 9th, and the countdown to launch is on for Rocket Lab's 23rd Electron mission from Rocket Lab Launch Complex 1 in Mahia, New Zealand. The name for this mission is A Data with Destiny, in a nod to our dedicated customer on this launch, real-time global monitoring and data provider BlackSky, through mission integration partner Spaceflight. My name's Muriel Baker, and thank you for joining us for our final launch for 2021. On your screen is a live view of our Electron launch vehicle ready on the pad as we wait for the call to proceed with launch from our launch director in Mission Control. We're counting down to liftoff right as today's launch window opens at 1:02 p.m. local time. If you're joining us from the United States, though, launch is scheduled for 7:02 p.m. Eastern or 4:02 p.m. Pacific. Our launch window today is just a touch over 2 hours, and we've got backup opportunities throughout this weekend next if we need to stand down from launch for any reason today. But today is looking like a good day to launch, with no red flags halting any of our launch procedures, and clear skies over the Mahia Peninsula, where our launch site is located, along with a clear shot to space and low Earth orbit for our customer satellites on board.
LD, GC on mission.
Go ahead, GC.
Umbilical arm and prime sequence complete.
Roger, thank you, sir.
Today's mission is carrying a pair of twin Earth observation satellites for BlackSky, and is our second dedicated Electron mission for the company in just a matter of days. With Spaceflight Inc. as their mission integration partner, BlackSky are rapidly expanding their satellite constellation as they scale up their service to provide high-resolution photos of Earth combined with artificial intelligence to deliver real-time analytics and insights to government customers and various commercial industries. Our most recent launch on November 18 delivered 2 of BlackSky's Gen 2 satellites to low Earth orbit, with another pair on board Electron today, taking off on an eastern trajectory from Launch Complex 1, heading to the same 430-kilometre circular orbit to join the constellation. It's been 3 weeks since that last launch on November 18, and a successful launch today would equal our quickest launch turnaround of just 21 days, previously achieved between flights 12 and 13. Now, those of you who joined us for that Love at First Insight mission will know that not only did we successfully deploy BlackSky satellites, we also brought our Electron booster back to Earth in another test of launching and capturing our Electron rocket for reusability. Love at First Insight was our third proof of concept mission to control Electron's return from space and recover it from the ocean after landing it there underneath a parachute. But more excitingly, the mission was the first time introducing helicopter operations to a recovery launch. We stationed it at sea 200 nautical miles offshore to observe and track Electron's first stage as it descended to Earth, and we've got some footage from that mission to show you. So with a successful liftoff and after clearing max Q, Electron completed a flawless separation of its first and second stage, as you saw there. And once that happened, Electron's booster re-entry was controlled by a cold gas reaction system that tilted it in such a way to better slice through Earth's atmosphere on the way back down. Our helicopter crew successfully tracked the returning rocket and completed communications tests in the recovery zone, bringing Rocket Lab a step closer to catching a rocket in the sky, bringing it back to the production complex for a blow-up, and then launching it to space again. And with the success of the mission and those recovery operations, we've proven small launch vehicles can be reusable. And as one of only 2 launch companies repeatedly recovering orbital class boosters from space, we're now moving to the final step in our plan to launch, catch and repeat by using a helicopter to capture Electron's booster by its parachute, to keep it dry and bring it back to our factory. So with some final modifications to Electron you can see there, and our recovery operations on track, we're looking forward to that very first helicopter capture taking place during a mission scheduled to launch in the first half of next year. We are coming up, though, to the go, no-go poll to determine whether to proceed with the final minutes in the countdown today, which will be run by our launch director, Joseph Carpico, from Rocket Lab Range Control in Mahia. Each of our operators will now check in from their stations to confirm their systems are operating as they should. Let's listen into the roll call.
This is the LD on mission, proceeding with the go, no-go sequence. Stage.
Stages go.
Avionics.
Avionics is go.
GNC.
GNC is go.
Beacon.
Beacon is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
Match is go.
MM.
MM is go.
LD sub.
LD subs go.
That concludes the go, no-go sequence. We are now T-minus 11 minutes, 22 seconds and counting. We are go for terminal count at T-minus 10 minutes. From this time, the 3-word hold procedure is in effect.
And with that, we'll be proceeding with the rest of today's countdown and moving forward to liftoff. Electron is our workhorse launch vehicle dedicated for small satellites, and if you've been following along with Rocket Lab's announcements, you'll know that we're building on Electron's experience as the second most frequently launched US rocket annually to develop another launch vehicle, Neutron. Just last week, for the first time, we revealed some exciting key details about our new rocket, including Neutron's unique design, materials, propulsion, and how we'll make it reusable.
This is Neutron. Let me show you a new breed of rocket where reliability, reusability, and cost is hard baked into the design from day one. So what does a 2050 rocket look like? Well, it should be designed to be reusable. It should also have engines that are able to be used over and over again, and engines that aren't stressed to their absolute limit. It should have materials that are advanced. Now that's what I call a 2050 material. This is not a conventional rocket. This is what a rocket should look like in 2050, but we're building it today. It is an absolute beast. It stands 40 metres tall, it has a 7 metre diameter at the base and a 5 metre class fairing. The team is flat out right now at full force developing it, because at Rocket Lab, when we say we're going to do something, we do it.
There are a few more details about Neutron that we're keeping up our sleeves for now, including where Neutron and its Archimedes engines will be built and launched from. But if our new rocket excites you and you're interested in joining the team to design, build and test it, we have several jobs in the Neutron program open now. To find out about these roles and to watch the full Neutron reveal video, head to our website for more.
S-band is switched to high power for flight.
Stage terminal checks.
Commencing stage terminal checks.
Stage 1 and Stage 2 high voltage batteries ready for flight.
GC, LD on mission.
LD, GC.
Yes, sir. Proceed with sequence 57, pad ready for launch.
Roger, sequence 57 in work.
With the liftoff coming up in a few minutes' time, let's take a closer look at Electron on the pad. Electron is a two-stage launch vehicle that stands 18 metres tall. Its black and white stripes are a visual effect caused by the rocket's liquid oxygen propellant, where ice forms on the outside because of the cold temperature of the liquid oxygen in the rocket's fuel storage tanks inside. The black comes from Electron's carbon composite structure, a material that is lightweight yet strong enough to withstand the pressure of launch. And powering the rocket are 9 Rutherford engines on the first stage and a single Rutherford engine on the second stage. These engines are 3D printed and named after the famous physicist Ernest Rutherford. We have an 11th engine on Electron also, called the Curie engine, after chemist and physicist Marie Curie. This propulsion system is housed within Electron's third stage, or kick stage, which we use as a orbital transfer vehicle to deploy the mission's payloads to their exact destination in space. The kick stage is carrying today's 2 BlackSky satellites to a 430-kilometre circular orbit after Electron lifts off the pad at Launch Complex 1 today. Now, while we're mostly known for being the transportation to space for satellites and spacecraft, these days we also take care of the on-orbit end of the space business too. Here's more about how we're building out our Space Systems division to become a one-stop shop for satellite missions.
Rocket Lab was founded to open access to space, starting with launch. Electron unlocked orbit for small satellites, providing them with a dedicated ride since 2018. More than 100 small satellite deployments later, and we're turning our attention to larger launch with Neutron, a next-generation rocket designed to launch the small satellite constellations of the future, enable deep space missions, and support human spaceflight. But launch is only one part of truly democratizing space access. To make it faster, easier, and more affordable to do incredible things in orbit, we're delivering an end-to-end mission solution that spans spacecraft design and manufacture, satellite subsystems, flight software, ground operations, and launch. To enable this, we've recently welcomed some new companies to the Rocket Lab family. Last year, we joined forces with the Sinclair Interplanetary team in Toronto, Canada, enabling us to supply our customers with best-in-class, flight-proven reaction wheels and star trackers. These crucial components have been incorporated into more than 100 spacecraft globally, including constellations and cutting-edge scientific missions. Sinclair Interplanetary reaction wheels and star trackers are incorporated into our Rocket Lab designed and built Photon satellites too, supporting our upcoming missions to the Moon, Mars, and Venus. But of course, before a satellite can operate in orbit, it first has to safely deploy from the rocket that launched it. That's why we recently acquired Planetary Systems Corporation in Maryland. As the leading provider of mechanical separation systems and satellite dispensers, the PSC team has 100% mission success heritage to date across more than 100 missions. PSC separation systems have flown on over half of the Electron missions since 2018. So having seen the impeccable craftsmanship of their technology up close, we're thrilled to be supplying our customers with trusted separation systems and dispensers, whether flying on Electron or any other vehicle. After a spacecraft is deployed, the real fun begins. That's where the Colorado-based team at Advanced Solutions Incorporated, or ASI, comes in. ASI's pioneering satellite flight software and GNC expertise have enabled some of the most ambitious missions humanity has undertaken, including exploring distant planets. The ASI team joined the Rocket Lab family in October this year, and together, we're supporting missions for aerospace prime contractors, U.S. DoD organizations, NASA, and commercial operators and constellations. By folding these industry-leading teams and proven technologies into our ever-growing space systems capabilities, Rocket Lab is delivering complete mission solutions for every step to space. We might have started with launch, but there's more than just rockets to this lab.
A very warm welcome to ASI, PSC and Sinclair Interplanetary. We are incredibly grateful to have you as part of the Rocket Lab family. We're coming up to just over 3 minutes now away from launch. Electron remains in good health, as well as the BlackSky satellites inside the fairing. The weather remains green and the path to orbit looks clear from Launch Complex 1 at T0. Soon we'll hear the call that LOX loading is complete on Electron, telling us that the rocket is fully fueled for launch. Electron's internal flight computers by then will have taken over the countdown to run the vehicle autonomously, with our launch director counting down the clock at T-minus 10 seconds. We're going to hand over now to Mission Control for the countdown to launch.
Shadow.
Yes, sir. Please confirm your go for launch.
LD Shadows go.
Vehicle is on internal power.
LOX load is complete. System is in recirculation. Anti-geysering is disabled.
Tanks are pressed for flight.
High flow engine purge enabled. Deluge activated.
T-minus 20 seconds and counting. Ten, 9, 8, 7, 6, 5, 4, 3, 2.
Discharge nominal.
And away we go. Our 23rd Electron launch vehicle is off the pad and on the way to space for this mission and progressing well on its journey to low Earth orbit. We've got a great daytime view from the rocket's onboard cameras as it approaches the point in its journey when it experiences the most amount of stress, otherwise called maximum aerodynamic pressure or max Q.
Cleared max Q.
There's the call out from Mission Control. Electron has successfully passed through Max Q and is continuing eastward off the coast of New Zealand. The first stage's Rutherford engines are firing red hot and nominal as we come up to a vital sequence of events in the vehicle's launch procedure. Electron will slow down just a touch before shutting off its main engines, what's called main engine cutoff or MECO. This allows for the clean separation of the first stage from the second stage before the second stage's engine lights up and propels the vehicle's satellites onto orbit. We should both see those actions on screen and hear the call-outs from our operators in Mission Control soon.
Stage 1 propulsion is holding nominal. Stand by for MECO in approximately 30 seconds.
Fifteen seconds to MECO.
SECO confirmed.
Stage separation successful.
Stage 2 ignition.
And there we go, that's confirmation of successful MECO, stage separation and second stage engine start. You can see the space optimized Rutherford engine glowing hot on your screen as it carries on in space. Now, since we've cleared the lower atmosphere, we no longer need the rocket's fairing to protect the satellites, and we need the fairing out of the way to be able to safely deploy the satellites. So soon that fairing will fall away as we get rid of the dead weight. Let's keep an eye out for that. And there they go, Electron's fairing halves have been deployed. We've got a short time gap now between this event and the next one coming up for Electron's second stage, which involves swapping out the batteries that power the second stage Rutherford engine. The mission is continuing nominally though as we approach that next milestone, with the second stage travelling at a speed of nearly 10,000 kilometres an hour at an altitude of over 130 kilometres. If you're just joining us, we have had a great start to today's mission so far. Electron successfully cleared the pad at Launch Complex 1 just a few minutes ago, and we are now well on our way to space, having completed a successful pass through Max Q, main engine cutoff, and stage separation to reach this point now in the mission. Electron's second stage, with the BlackSky satellites on board, is headed to a circular low Earth orbit 430 kilometres above Earth, where they'll join the rest of BlackSky's constellation of Earth-observing small sats, two of which we deployed on our last mission just 21 days ago.
Throttling down.
Stage 2 propulsion holding nominal.
We're coming up to a milestone unique to Electron soon, the swap out of the batteries that our Rutherford engines draw their energy from to continue, as our engineers say, chooching. The vehicle has run through the set of batteries we started with at liftoff, and so now the second stage of the vehicle needs to swap over to a fresh one to keep things going. We call this move the battery hot swap. You should hear that call come from Mission Control shortly, but keep an eye on your screen too, as often you can catch a glimpse of them falling away.
Hot swap successful.
And so there they go, and that was the call for a successful battery hot swap. Coming up in the next couple of minutes will be the second engine cutoff on the second stage, or SECO. This manoeuvre follows pretty much the same procedure as main engine cutoff, where the Rutherford engine on the second stage will shut off ahead of final separation of the vehicle between the second stage and our kick stage. There will be a bit of a gap between that final separation and payload deployment, as this stage separation places the kick stage in an elliptical orbit of Earth first. I'll explain what happens after that point once we receive confirmation from Mission Control first of SECO and stage separation. You can see the second stage Rutherford engine burning bright on your screen there, with Electron well on track to deliver the BlackSky payloads to orbit in around 50 minutes or so. The vehicle is travelling at more than 19,000 kilometres an hour with an altitude of nearly 200 kilometres, and everything is continuing as expected with our stage 2 burn.
Voltage battery discharge holding nominal.
quick reminder for those who are just joining us, while our last launch was a recovery mission furthering our development of a reusable launcher, this mission is not, but we will be attempting our first aerial capture of Electron in 2022, and we can't wait to bring you more information as we get closer to that mission. Meanwhile, Electron's vacuum-optimized Rutherford engine is putting in the work ahead of kick stage separation in about a minute and a half.
Entered stage 2 burnout detect mode.
A check-in on the telemetry in the top right of your screen, and you'll see Electron is continuing on its way to orbit, travelling at a speed of nearly 25,000 kilometres an hour and an altitude of over 190. Now, as I mentioned before, coming up next is second engine cutoff, or SECO, which will see the engine on Electron's second stage power down ahead of kick stage separation scheduled a few seconds after.
SECO confirmed.
And there we go, with the dimming of the Rutherford engine on your screen as you saw. That, along with the call from Mission Control, confirms that we have had a successful SECO and second stage separation from the kick stage. Today's satellites are headed to a circular orbit, so while the kick stage is on that elliptical first pass, it ignites its Curie engine to course correct and set it on its correct trajectory for payload deployment. That's set to take place in the next 45 minutes or so. Now, while unfortunately we won't have live video of payload deployment on this mission, I'll be coming back to you on this webcast with an animated simulation of the end of the mission and to listen out to those final few calls from Mission Control. We'll take a bit of a break now and leave you with the tracking data of where the kick stage is over Earth. If you've got a telescope handy and the kick stage is over your part of the world, see if you can spot it in the night sky. I'll see you back here soon.